The upcoming soil forming processes that they are not so widespread, but they may occur locally in Liberia. And the first one is salinization. It is a localized process. It may occur in coastal lowlands, estuarine environments, tidal flats and mangrove zones, and poorly drained sites influenced by seawater or brackish water. And the typical appearance of these soil forming processes is the appearance of soiled minerals in the soil profile and or on the surface. Podzolization. Podzolization is not, again, it's not a widespread soil forming process, but it turned out, based on one of the submissions during the field work, that podzols exist in Liberia. So that is why we included into the list of soil forming processes. Podzolization in Liberia, it seems that it is a localized process, especially in sandy coastal environments. Podzolization is favored by sandy, quartz-rich parent material, very acidic conditions, strong leaching, and downward movement of organic compounds like iron and aluminium. The typical field indicator of the podzolization is having a dark surface horizon, and a bleached organic rich, pale bleached illuvia horizon, as you can see here, darker reddish brown so-called sesquioxide accumulation in the subsoil, and a very strong horizonation. Sodification. Sodification, again, it's not a widespread process in Liberia. It may occur in coastal lowlands, estuarine environments, marine or brackish sediment zones, poorly drained coastal sites with saline influence. During sodification, sodium accumulates in the soil, and the subsoil becomes dense and poorly structured, and the pH of the soil becomes very high. Shrinking and swelling occurs in areas where so-called high-activity shrinking and swelling clays dominate, which expand when they get wet and shrink when they are dry out. This leads to the development of surface cracks, slickened sides, and wedge-shaped aggregates. Processes that are very unlikely in Liberia: accumulation and cementation by calcium carbonate. This is a process that is dominant under arid climatic regions. Another process that is very highly unlikely in Liberia: accumulation and cementation by gypsum. This is also a typical process in the arid areas. And another one, accumulation and cementation by silica. This is also process dominant in arid environments. A few additional processes: sedimentation, which is basically the accumulation of material transported by rivers, coastal waters, or gravity. It produces layered deposits with abrupt changes in texture, color, coarse fragment content, for example. Another process, colluviation, which is downslope movement and accumulation of soil material under the influence of gravity, often enhanced by water. Additional process, volcanic deposition, which is not widespread in Liberia. It cannot be expected. It is the accumulation of ash and other volcanic ejecta that is transported through the air and deposited as a new parent material. And usually it creates distinct, often uniform layers that bury pre-existing soil surfaces. And the last process that we just briefly mentioned is erosion, which is the removal of soil material from the surface, typically caused by intense rainfall and runoff. It reduces the thickness of the soil, truncates the soil, exposes the subsoil layers to the surface, and erosion also alters the natural vertical development of the soil. And this is the last process that we discussed today. So this was just a very short recap. And it's very important to mention that soil forming processes, this is just a very short list of processes that we can see on the right side of the slide. It is responsible for the development of the soil horizons in the soil. And these horizons are designated with different kinds of codes. That is what we are going to discuss today. So the topic for today is designation of horizons and layers in the soil. Here we can see some examples. If we open up a book, manuscript, paper, MSc or PhD thesis about soils or dealing with soils, we may find data sets, data or pictures of soil profiles with these kind of horizon designations. So when we open a soil profile, the first thing that we have to do is to delineate the horizons. We delineate the topsoil, the organic matter rich topsoil, and we look for changes in the soil profile, and we mark the boundary of those changes, and these will be the horizon boundaries. And these horizons that we delineate, these are basically the results of the soil forming processes. And the main task during the field soil investigation is to identify which soil forming process has been responsible for the development of a particular soil horizon in the soil. And when we are able to identify which soil forming process is responsible for the development of these horizons, we can add these kind of codes that you can see on the slide, these O, A, B capital letters, and small letters like the P, the T, and the C, the V. So these are basically those designations that indicate which soil forming process was active or has been active in the soil profiles in the soils, and this is the horizon designation. Here we can see some examples. I won't go into very deep details now. These are just examples how these horizon designations should look like. Here you can see, okay. And as I mentioned previously, basically we have two types of letters in these horizon designations. We have capital letters and small letters. Let's start with the capital letters. These are the so-called master horizons. We have two types of master horizons. We have the mineral horizons and the organic horizons. The mineral horizons are horizons in the soil that are built up mostly mineral particles, like 95% of mineral particles, and the organic horizons are horizons in the soil that consist mostly of undecomposed organic matter in the soil. Let's check them one by one. Let's start with the organic horizons. We have two types of organic horizons, the H horizon and the O horizons. The common property of both horizons that they are dominated by undecomposed or just partially decomposed organic material. On the left side, you can see H horizon. On the left side, you can see an H horizon, a peaty soil, and on the right side, you can see an O horizon, which is the uppermost horizon in a forest soil. H horizons are organic horizons that are dominated by organic material formed from accumulations of undecomposed or partially decomposed organic material in water-saturated environment. Just very briefly, to have stable decomposed organic matter humus, we need a favorable environment. And in a water-saturated environment where the oxygen is lacking in the soil, this decomposition cannot take place. And in these environments, like in marshlands, like in peaty areas, we see these age horizons. So these are basically the peaty soils. And the organic matter content of these soils with these horizons can be even more than 80%. The second organic horizon is the O horizon. It's very similar to the H horizon, but fundamentally they are very different. The O horizons also consist of undecomposed or just partially decomposed organic material, but as you can see, these horizons consist of leaves, needles, twigs, mosses that accumulate on the surface of mostly forest soils. And in this environment, the soil is not saturated with water for prolonged periods. So these horizons form in a well-aerated environment. Why do we see the undecomposed organic matter in these horizons? Because in forest environments, where the chemical environment is not favorable for organic matter decomposition, the material of the plants are also not favorable for rapid decomposition, and many other factors contribute to the slow decomposition of organic material in these environments. So just summarizing, H and O horizons are those horizons that are so-called organic because they are mostly contain organic matter, undecomposed or just partially decomposed organic matter.